Good morning, Doctor. Today, BFC 35403 Geotechnics will be presented by Group. Let's introduce our team member. For me, myself, Lo Shen Abdul Aziz bin Mayani, Wong Yiman, Gentleman Anna Peter, Muhammad Arif Aiman bin Muhammad Razi, Muhammad Faiz Firdaus bin Zahar.
Let's start with introduction of our project. When a weight is applied to the earth, settlement is the downward movement of the ground. The vertical effective stress applied to the soil is increased by the load. The cone penetration test and field density test was studied in our project. The cone penetration test useful for determining the bearing capacity of soil and forecasting settlement. For the field density test, measure the in-place density and moisture content of soil. They provide data for designing foundation, embankment, and other geotechnical structure to ensuring it's safe and reliable.
My name is Muhammad Faiz Firdaus bin Zahari. My matrix number is CF220016. Today I want to represent about cone penetration test, which is CPT. Cone penetration test is one of the most widely accepted in situ testing techniques in geotechnical research globally. CPT test has several benefits over conventional soil investigation technique, such as drilling and sampling. Geotechnical engineering specialists use the result of cone penetration test to determine the quality of soil, how the ground would likely respond under varying earthquake shaking intensities. So for cone penetration test, this is one example that I get from the Google. So this is the example data obtained from CPT test, which is the slip friction, tip resistance, and poor water pressure. So this is the equation for cone penetration test. For cone resistance, the formula is QC divided by AC. So for slip friction, the formula is QS divided by AS. And for the friction ratio, the formula is FS divided by QC and multiplied by 100. And last but not least, the connection cone resistance, the formula is QC plus U2 multiplied by 1 minus A. So, for the relationship between data obtained from CPT and settlement, the data obtained from cone penetration test play a crucial role in estimating the settlement of soil under loads. The parameters are essential for classifying soil type and delineating soil layer. Once the soil layer are classified, the CPT data can be used to estimate key geotechnical properties necessary for settlement analysis. Empirical correlation between CPT parameter and soil properties are crucial for these calculations.
My name is Abdulaziz bin Mariani with metric number DF220123 will present about case study of settlement using CPT. There are two methods used to identify settlement in this journal, which are first, tangent modulus method. It estimates soil modulus by dividing stress by strain to calculate future consolidation settlements considering soil condition and pore water pressure. Next is Fellinius equation, proposed using basic CPT data to estimate modulus number utilizing stress state analysis and CPT dissipation tests with consolidation settlements depending on the difference between actual and final effective stress. From the figure of the result, we can see major settlements occur at depths where clay pre-consolidation pressure is close to current effective stress, which is 6 meter to 20 meter. More settlements are calculated between depths 11 meter and 20 meter due smaller modulus number. Stratigraphic variation, prephatic surface drawdown, and lateral movement and soil suction can increase settlements. Installing vibrating wire piezometers in clay allows for more precise estimation for vertical effective stress. In conclusion, the CPT-based method captures settlement time curve and is recommended for sites with low stratigraphic variability, spacing out CPTs and using more CPTs near sensitive structure, along with traditional boreholes, ensure reliable data and high-quality samples for lab testing. That's all from me. Thank you.
Good afternoon, good evening, everyone. Today I will briefly discuss some of our points from the study case that I found regarding about field density test and soil settlement. So the case study that we have found, the name of it is reliability of standard penetration test to determine bearing capacity of fine grained soil. A case study in Addis Ababa soils by Beza Gabrimelak. It discusses about some aspects and points that correlate to soil settlement. So first, the accuracy of standard penetration tests reading is crucial. Variations in test methods such as different hammer types and drilling rates can lead to inconsistent end values which could impact the reliability of our settlement predictions. Secondly, the geotechnical properties of soil, including moisture content and plasticity index, play a significant role in settlement behavior. Higher moisture and ductility levels can cause greater settling when the soil is loaded, making it essential to understand these properties for accurate analysis. Lastly, the case study has developed empirical correlations between SPT results and settlement behavior. These correlations provide a practical method for predicting soil settlement, enhancing the accuracy of our forecast based on field observations. In summary, ensuring consistent SPT readings, understanding soil properties, and using empirical data are vital for reliable of-soil settlement predictions. Thank you.
Right now, I'm going to explain about the field density test. This test is used to determine the in-situ density and the moisture content of soils. It's crucial for assessing the soil compaction quality on construction sites and making sure it satisfies the requirement and standard needed for secure and safe root beds, embankments, foundations, and other structures. There are two major methods to carry out our field density test. So, our first method will be our nuclear density gauge method. This method is using a nuclear density gauge to measure the density and moisture content of the soils. It consists of a radiation source that emits particles and a sensor that counts the received particles that are either reflected by the test material or passed through it. The diagrams below show the component of the nuclear density gauge. The soil's density can be determined using backscatter techniques, and the soil's moisture content can be determined by using the attenuation of gamma
My name is
radiation.
Lima Peter, AF220038. So today I'm going to discuss a little bit about sand method, which determine the in-place density of soil that consists of substrate of sand filled into the excavated area. First thing first, for the dry density can be calculated by weight of sand divided by the volume of the test hole to evaluate the strength or stability of foundation, embankments, and other structure that built into it. And only applicable for granular soil and hard soil, which this is suitable and easy to initiate as a SI investigation. For the sand method, it requires three things: unit weight of calibrated sand, weight of calibrated sand in the funnel, and maximum dry density of soil that being compacted. For the unit weight of calibrated sand, it need to require to pass through 1 mm safe and retain on 600 mm for the unit weight of calibrated sand. Second, for the weight of calibrated sand in the funnel, we need to excavate the site as deep as 15 cm, as well as collect the samples by using plastic bags and ensure there is no moisture loss, and known as the weight of excavated. Now, we're going to fill the sand apparatus and with the calibrated sand, as denoted as the WN1, and allow the sand to fill the excavated site and denoted as WN2. For the setup, we're going to remove the weight of the remaining sand and the weight of conical head of the sand from the sand apparatus, and to obtain the calibrated sand. And we can obtain the volume of the sand by using weight of the sand divided by the unit weight of sand. So for the bulk density, we can use weight of excavated divided by volume of hole, which determines the weight density of the area. For the testing of the moisture content, we can conduct over drying method or psychometer method.
Now, I'm going to explain the relationship between the data obtained from FDT and settlement. The geotechnical settlement of soils refers to the soil movement in the vertical direction typically induced by stress change. From field density tests, we can obtain the data of in-situ density and the moisture content of the soils, which are crucial in geotechnical engineering, particularly when dealing with settlement problems. With the aid of field density tests, we can obtain the compaction level of the soils. Engineers can determine whether the compaction level of the soils needs to be increased to prevent settlement, or they can determine the relative compaction of the soils by comparing the field density with the maximum dry density that found from proto tests. The next information we can get through the help of field density tests is the properties of soils. Engineers can determine the soil's porosity and the void ratio of the soils. The shear strength of soil is highly dependent on its density because the particle cohesion and shear strength are improved as density increases because the closer packed particle have more contact points and interparticle connection. The last information that engineers can determine is the settlement magnitude. Engineers obtain the in-situ density and moisture content of the soils. They can classify the soil and conduct odometer tests or triaxial tests to determine the compressibility parameter of different soil types. The formula are given in our project.
Now, come to the conclusion of our project. Settlement issue using the cone penetration test and field density test is a cornerstone of geotechnical engineering. Cone tip probes are driven into the ground, and the cone penetration test measure the resistance they meet. This allows for detailed insight into soil density, strain, and stratigraphy. Field density tests verify that the soil has been compact to the necessary requirements by measuring the soil's moisture content and in-place density. By providing comprehensive data on soil properties and compaction, these tests enable engineers to design structures that can withstand the challenge of settlement, enhance the safety and longevity of constructions, reduce the risk of costly repair and maintenance. As the field of geotechnical engineering evolves, the cone penetration test and field density test will continue to play a crucial role in ensuring the stability and reliability of built environment, particularly in mitigating settlements-related concerns.
That's all from Group 2. Thank you.